Hi, I'd like to welcome everybody to the second webinar of the C3.ai Digital Transformation Institute. The agenda for today is primarily to explain how the C3.ai software suite works. But just for those of you who may have missed the first webinar, I'll give a very brief introduction to what the Institute is about. And then others will take over and talk about the integrated development studio, data science on the C3.ai suite, C3.ai DTI curriculum, and then we'll have some question and answers at the end. Just by way of introducing myself, I am Srikanth. I'm the co-director of the Institute at Illinois. The other co-director is Professor Shankar Shastri, who's at Berkeley. And C3.ai DTI's mission is to put together a consortium of leading researchers and scientists from all over the world to advance digital transformation. What do we mean by that? We mean the use of AI, machine learning, IoT, cloud computing, the confluence of these technologies to transform society, business, government to the benefit of everybody. Next slide, please. Yeah. And the consortium has multiple members, C3.ai, Microsoft, which provides C3.ai provides the software suites for the researchers of the Institute. Microsoft provides the computing capabilities, and the academic partners are Illinois, CMU, Berkeley, MIT, Princeton, and University of Chicago. Supercomputing support is provided by the National Center for Supercomputing Applications at the University of Illinois at Urbana-Champaign and the Lawrence Berkeley National Labs at Berkeley. So at a very high level, the C3.ai Digital Transformation Institute has multiple programs. The one that we are currently focused on is the Research Awards, and some of you may have seen the first call for proposals focused on the COVID-19 pandemic. But we also have other programs, and you will get to know those as the year progresses. We'll have a visiting professor and scientist program, a curriculum development program, an educational program, an industry program. But I also want to emphasize again that we provide a very unique data analytics platform consisting of the C3.ai software suite on the Microsoft Azure cloud computing platform. And we would strongly encourage everybody to make all the results available to the world. So we want everything to be open source so that it benefits everybody. So before I turn it over to my colleagues, I just want to mention that this is the list of topics that we mentioned under the first call for proposals, which is an attempt to mitigate the COVID-19 and also to prepare ourselves for future pandemics. I'm not going to go through this list, but anything that you can do to address the current pandemic and anything that you can do to get ourselves ready, the science behind combating and modeling and being prepared for future pandemics and to help control today's pandemic. The pandemic that we are encountering today would be welcome, but our main focus is on the use of AI ML technology, and we really hope that all the proposals would very well leverage the software and cloud computing facilities that we make available. So I guess now I'll turn it over to Human.
Thank you, Srikanth. So this is Human Mazadi. I'm the Chief Product Officer at C3.ai. And what we wanted to do is really provide you a short overview of C3.ai and then actually show you software. So show you kind of our integrated development studio and how data science is done on C3 to give everyone a better perspective of how you would use the platform. So C3.ai has been around for about 10 years, and we are a software suite for digital enterprise transformation. Founded by Tom Siebel, we've been building a next generation enterprise AI platform that brings together AI, machine learning, big data, Internet of Things, and distributed computing. And it's deployed today at some of the world's largest corporate commercial companies, and also in the federal space and defense space in the US Air Force, US Army, and others. We've been really going at, the software is used to do things like stochastic optimization of inventory, to predictive maintenance in the oil and gas space, to the smart grid, the distribution grid of Italy as an example, to do data ingest, machine learning at very large scale, being used in banking to do use cases such as anti-money laundering, cash management, aerospace and defense, healthcare, smart cities, and others. So a platform that's been used by cross industries by some of the largest organizations. And we are the world's leading provider of AI, IoT, and big data applications as a company itself. And what is C3.ai? So the way to think about it is it's a platform as a service, a data integration platform, and a rapid AI and application development platform. It is scalable, it is distributed in nature, and it's proven at large scale. We have spent about 10 years of software engineering building out this platform, about a $650 million software investment. And what's important, I think important in this conversation and the demonstrations that we're going to give, it's an open platform. You're able to use technologies or algorithms that are external, plug them into our machine learning pipelines, into our model-driven architecture as well, and we're going to demonstrate that to you. So C3, this is the architecture of the C3 the platform itself. So C3 is not a product or a platform to use for tinkering and just playing around with kind of constant small data sets in some way. The idea is we're really an end-to-end platform to ingest data, develop features and machine learning, and later on operationalize it at scale. It's a model-driven architecture is how we've approached this. So we've abstracted away a lot of the complexities from data to processes to machine learning to the UI itself, and allow people to actually use our tooling, what we're going to demonstrate to you, the integrated development studio, to actually access and modify the metadata related to the data integrations, the application development, the machine learning. C3 itself has, if you look on the left-hand side, has a set of pre-built connectors to data sources. This can be, Oracle, SAP, Salesforce, file systems like ADLS or S3, to streams of data, Kinesis, Kafka, Event Hub, and others. We can persist that data, apply machine learning, and then use our model management capabilities to actually understand the results of your work. Now, on the open side, we have a Jupyter interface to our platform. We have an RStudio plugin to our platform. We have a VS Code and Eclipse plugin as well. So you don't need to just use our tooling. You can easily connect Jupyter to C3 and do your work, and we'll demonstrate that as well. So, what's important is that C3 is a model-driven architecture, really kind of thought through next generation of these AI-based applications and development of these applications. So we're simplifying kind of the need to develop lots of code. It's really a low-code, no-code way to do it, but it's very open in how you access this. And what's important is that, again, it's not to tinker with, but it's really a way to build robust, scalable, and production-level AI applications. It has been, just quickly, it has been named a leader by, Ovum, Omdia. It's been named a leader by Forrester, all in analytics and data, all in security and platform differentiation, and ease of use. So, and it's #1 in strength and market offering as well from a competitive perspective. Also, Bloomberg is rated at the #1 offering as well. So a lot of external validation in addition to the customers. So really what C3's been doing is building out this next generation platform that allows you to have a unified federated data image, allow you to, from a business perspective, allow you to understand the business processes in an organization, and then apply machine learning to solve different application use cases, whether in the manufacturing space, we're looking at things like on time and full, demand forecasting, bill of materials, and others, or yield. So if I just break apart quickly the platform, and I think we'll go to the demonstrations by Riley and Jake, the platform has a set of capabilities. There's the core platform services. These are application platform services, kind of ability to run on the clouds and leverage native cloud services such as Event Hub or ADLS or others, and lots of security within that as well around the objects themselves. To IDS, which is our tooling to allow you to integrate data, perform machine learning, and turn that into a user interface or application. And then we have a set of pre-built object models and apps that are leverageable from foundational elements to predictive maintenance, to fraud, to health, that can then be extended as well. Within each of these capabilities, within the IDS and data, you're able to do things like raw data exploration. You can leverage the pre-built object models. You can leverage the data connectors, auto mapping, data virtualization. All of those are available within our data studio. And again, Within data connectors, these are the data connectors that we have out of the box today. And again, we're continuing to add as we go. But as I mentioned, file systems, AWS or Azure services, and enterprise systems as well. To the ability to quickly build a UI on top of the data that you've or the machine learning models that you've developed, so you can actually expose that through a metadata-driven UI designer. We have a Microsoft VS Code plugin as well to develop these applications, and then the development of analytics as well. And then in the machine learning space, again, as we said, we've built a very robust kind of composable and extensible machine learning pipeline capability. But within that, you can actually use AI frameworks, TensorFlow, Keras. You can use Spacey. You can use third-party support for Pip and CRAN and MATLAB, and that's what Jake's going to cover as well and demonstrate. And really the way that we've thought through machine learning within the platform is all the way end-to-end from a C3 perspective, from data operations to data exploration to feature engineering to model development, model deployment, inference and operations, and then model monitoring and maintenance to the application itself. So we've really been thinking about this as an end-to-end process that our platform enables to build out these applications. And within that, you can kind of see how we've thought through the different components, from correlating raw and model data to reviewing data sufficiency, prototyping the ML features, training and tuning and testing the models, to then developing and training the pipelines, to then turning it into a potential application that can be used by others. And although I think in the case of DTI, a lot of the users are going to be using whether it's R or Python against the platform, we do also have a visual drag and drop interface that's available that allows people who don't want to write code to drag out data sources, connect them, apply, prepare the data, apply analytics, AI and machine learning, and then output that. So this is it's a visual no code environment that we've developed as well that is also available and may not be the primary use case here, but something that is available. And it's called C3.ai Ex Machina. So what we would like to do is really have Riley demonstrate initially the integrated development studio, which is how people can access their development environment, create the objects, extend objects, and then access things like the machine learning studio, access Python from there. And then Jake Whitcomb will come in and actually walk through how do you do data science on C3 specifically, given that's where the large interest is. So I'm going to hand it over to Riley.
Thanks, Suman. I think I'm live now, so. Not quite. I think I'm good now.
Yeah, you're all set.
Love it, thank you. So yeah, my name's Riley and I'm the Director of Developer Experience. And in the 10 minutes or so that I have with you guys, what I want to show you is sort of why developers choose the C3 AI platform. When you think about a software project, whether that's in data science, data aggregation, you want to build a fancy user interface, there are a lot of things that you have to deal with that are frankly more an annoyance than anything else, right? Which version control system are you going to use? Where are you going to put your code? How are you going to set up a continuous integration process? Who's going to set up the database? How are you going to connect to the database? What if there's two databases? What if the data is in a URL? Are you going to have to go hit that URL yourself manually every couple days? What if you want to collaborate with people and you want to be able to have your own space but share resources with people? What if you want to make sure that you can install the right libraries at the right times without conflicting with your colleagues? And C3 is really a platform that solves those problems, gets them out of your way, and allows you as a data scientist to focus on the problem that you're trying to solve. So what I'm doing here is I'm showing you what's called C3 IDS, which is the Integrated Developer Suite. And this basically has all the tools that you need to build an application. Whether that application is primarily data science and machine learning driven or primarily workflow driven, whatever it is. Jake is going to focus on the machine learning Jupyter Notebook integration type stuff. And I'm going to kind of show you the things that are around that. So the first thing I want to talk about is that the reason why you do software is to build something that works, right? And if you're going to build something that works, there are best practices that you should follow. Like you should have a development environment that's not the environment where you have live users connecting to it, for example. And C3 really provides a framework for all those things. So right within this tool, I have everything that I need to build, deploy, and operate a big data application and collaborate with a team. So the first thing you do is you develop an application, you release it, you operate it at scale. You might try to sell it or find something else that you want to buy or share for free. You want to be able to access the documentation and kind of take you through the entire application lifecycle. So within develop, there's like one button in IDS that if it was the only thing in IDS, it would save your life, which is this button right here, create application. By clicking this button, what happens is an individual tenant in this cluster of resources running on Azure is created. That means that you get for you and whoever else you invite your own SQL database, NoSQL database, file system store. You get your own resources for running Jupyter in a container, et cetera, et cetera, et cetera, and you don't have to think about it. You also get your own URL where your application is live. It feels a little bit like Heroku, but for, shall we say, big data applications. What I have here is I have 3 applications that I'm working on. And in this particular example, each application only has one branch going. If you have a team and each person is working on their own piece of this application, you might see multiple branches here. And of course, I can create more like this. So here I have an application called Lightbulb testing. Lightbulb is our Hello World application. Can you, by looking at data from smart bulbs, including how much light they're producing, their temperature, how many times they've been switched on and off, can you predict which ones are going to fail when? And then there's all kinds of fun things you can do with that. And so in this application, I can work on it. And we have a series of tools for getting you through the entire life cycle of one of these applications, right? You need data from somewhere. You're going to turn that data into time series because you're going to generate from those time series features that you hope are predictive of failure in your smart bulbs. You're going to use those features to perform machine learning, and this is where Jake's demo is really going to focus. And then all of that needs to go into a user interface so that you can give people an interface to interact with your data. There are other things that are important when you start going from an experiment to a production application, like security, right? Certain users might not be able to see everything. And then we have full source control bundled right in. Now, I mentioned that I got my own URL that was created for me automatically, and also a branch of Git of my Git repository was created automatically. So if I'm not like a Git wizard, doesn't matter. I don't need to be. Within each of these tools, as I interact with the metadata of the application and adjust it, commits will automatically be made to the Git repo so that if I have a colleague that's using the command line and a text editor or Jupyter running on their machine or whatever it is, I can be using this system and we can collaborate through version control. I'll probably have time just to show you one tool here. And so the tool I'll choose to show is this, what we call time series designer. So for a smart bulb, I might have certain what we call metrics that I think are interesting to know. How much power is it consuming? What temperature is it at? How much voltage is it using? How much light is it producing? And what I can do here is I can start to work on my metadata. So here I see basically the definition of my calculation, right? So take the average of the average, space and time of all the lumens data for a smart bulb. And then I can test it from, let's say, 2012 to 2013 chart, and I get my data. Right now, I can zoom in, check it out. Maybe I don't want to look at it at a day interval. I want to look at it at an hour interval. There it is. And maybe I find that I don't actually like this signal. I think it's wrong. I want a different signal. So I actually want to know when it's greater than 500. Let's try that. Okay, well, here 100% of the time it was over 500. 50% of the time it was over 500. 0% of the time it was over 500 over time. And so I can use this as one step in an application, and this is just writing metadata back to my GitHub branch to construct my calculations here. Now, we have a series of tools, and I'm going to not have time to go through all of them, but these become eventually the signals that you're going to use for doing machine learning on. So if, for example, the amount of light it's producing is 50% of the time above 500 lumens, that might be predictive of something later on. And I think you'll see that in a later part of the demo. So there's many tools. This is just one of them. There's also UI designers and data connection facilities, but there's also full application lifecycle management in here. So every time someone makes a commit, I would like to run all the tests, right? And I would like a version build. Okay, well, this just happens automatically in the C3 platform. You don't have to worry about setting up Jenkins or choosing whether you're going to use Jenkins or something else. It's just all set up for you. And for each commit automatically produces a versioned artifact. I can see how many tests are passing. We also have fully integrated documentation right in the tool. And one of the new things we're excited about, and we think is going to be actually really useful in the DTI project for you guys to share work that you're doing, is the marketplace. So you can automatically publish something that you think is good to this marketplace, and it will show up here as something that your colleagues can use in their own work if you choose. This is kind of there's also fully integrated documentation. So if I want to know about, how to manage security on the C3 AI suite, or how I want to connect to a certain type of data structure, it can load here. Let's see if this will. So, how to do testing, collaboration, using Jasmine, a security guide, tutorials in Jupyter Notebooks, understanding time zones and how they manage time series. We have a series of documentation articles written for all levels of experience that really help people build applications. So the thing that I want you to take away from this section of the demo is that as a data scientist, what you want to focus on is data science, and Jake will show you specifically how that's done. You don't want to focus on setting up servers, connecting to databases, worrying about your continuous integration process or testing, worrying about choosing a library for building a user interface, though you could choose if you would like to. So this is C3 IDS, and as a user of, as a member of the DTI project, you'll get access to this as the window for creating your projects, starting those projects, and then you're probably an expert in data science, but you might not be an expert in something else. And so using a low-code tool can really help you accelerate the development of building full-fledged applications on the C3 AI platform. Thank you.
Thanks, Riley. So what I want to go through next is machine learning on C3 AI Suite. And this is going to build off of Riley's demonstration of IDS and also go into some details of specifically how I can use Jupyter Notebooks and install custom libraries, and I'll provide a demo of that. First, what does data science look like in C3? Here's the way to think about it. This is an interesting paper, Hidden Technical Debt in Machine Learning Systems, where it describes that in scalable ML systems, the algorithm is actually only about 5% of the code. And so what C3 is in the business of is focusing on all of the sort of glue that you need to operationalize your algorithms at scale. Things like auto-scaling infrastructure, monitoring, logging, serving, automation, et cetera. The algorithm itself, the 5% is the core focus area of the data science process, and making sure that we come up with models that are solving the problems that we're setting out to achieve. And to do that, throughout the life cycle, we need to rely on a number of different open source libraries. And so as well as open source tools like Jupyter, which I'll demonstrate today. Now, C3 extends beyond that. We extend quite a bit into the data integration and data exploration phase, where in the environments that you'll have access to, we'll have preloaded COVID-19 data in a data lake, and all of that data management is accessible so that you can view the transformations, understanding the data lake, view all the metadata that Human was talking about. And then upstream of the model experimentation process that happens with open source libraries that I'll show you how to install, there's a bunch of capabilities in C3 AI Suite out of the box for operationalizing those models, monitoring them in live production applications, building UIs to continually monitor things like drift analysis and continually update and retrain those models. So to do this, we've taken a sort of a multi-mode approach for data scientists, where you have a low-code environment, which is Jupyter, where you can use APIs to automate a lot of the time-consuming tasks for you. You can write code directly in Python or JavaScript and expose those as APIs. These are the models or the what we call C3 types in the model-driven architecture. And those are then shareable across the entire organization or your data science team for future projects. And we also have the no-code environment, which is ML Studio, which Riley was talking about also in context of the IDS broader set of visual tools. And in most cases, what we're starting to see in the industry is data scientists are using a combination of these, really no code for organizing experiments, but still spending most of their work in Jupyter Notebooks. So that's what we've prepared for your environments as well. An example of the low code is, just time to kind of give you an example of one of these services is a service called C3 ML Pipelines. And what pipelines allow is you to compose multi-step graphs that are scalable machine learning processes, right? So if you have, for example, you want to do object detection using Keras with a ResNet 50 backbone from RetinaNet, you can use out of the box Keras pipe, and you can, maybe precede that with some data pre-processing, for example, to do some image extraction from PDFs. So let's say many of these pipelines are available out of the box, but of course you can extend and build your own. And this is an example of the extensibility of the objects that are provided in the C3 AI Suite. So you can build additional objects, or you can extend on these services that are already available out of the box. What I want to show next is a demonstration of the no-code experience as well as the low-code Jupyter Notebook, what we call ML Studio. So let me move over to my demo environment. And now I'm back in IDS, where Riley was just showing you the time series designer, and now we're in ML Studio. Initially, I'm in the context of an application that I'm building, or a project. One of your projects will look like this, and you'll have your own ML Studio instance. Now, within this, I may have multiple folders that I create, what we call ML projects, where I can organize my different machine learning experiments and simulations, et cetera. The reason we have projects is not only for organization, but a lot of our automated prediction and deployment is at the project level, because many applications are actually trying to solve multiple machine learning models. So let's go into one called DS Demos. We do provide a bunch of tutorial notebooks, et cetera, out of the box that you can explore. In DS Demo, I have a number of notebooks. I have notebooks experiments. These are sort of automated jobs or workloads, like AutoML workloads for hyperparameter optimization. There's a model tracking module for looking at my model performance over time. Ex Machina is the no-code drag and drop visual analytic experimentation data exploration tool that Human mentioned, and a model deployment module. In notebooks, what I can do is I can launch just like I would expect in any sort of Python, or IPython or JupyterLab environment. I can click on one of these and spin it up. What's different about our notebooks is we provide an auto-scaling cluster behind the scenes that are providing compute in terms of memory and CPU resource isolation for the data scientist. So as a data scientist, I can choose a medium memory machine or any of the sort of predefined containers that define the runtimes that I want to use. Before I go into this, let me go back and show you how I set those up, because I think installing the runtimes that I'm going to use, and installing those libraries that I'm going to use in my Jupyter notebooks is an important step. So I have a list of my runtimes when I click on this tool called App Settings. And in App Settings, I have here are a bunch of Python runtimes. I'll click into one called MLUtilsplot as an example. Or actually, I think I heard there's this interest in TensorFlow. So let me pull up TensorFlow. You can see we already have a number of TensorFlow runtimes pre-installed, so you can install different versions of the libraries. And the importance of that is many times, if you build a model in prior version 1.x of TensorFlow, and you really rely on those capabilities, we want to make sure those runtimes are frozen and available in the environment, so that as you work on your algorithms on newer versions of C3 AI Suite, you're still using those original TensorFlow libraries, for example. In here, I can select the version of Python. I can add repositories. For example, if I have a library in Conda Forge, I can add a new package repository here for Conda or pip. And then from here, I can add different libraries that are contained in those open source repositories. For example, anything you can imagine here, TensorFlow being one example. And I can select the latest stable if I want the system to go and solve for the latest stable. Let's say I want to fix on TensorFlow 2.0, I can leave that fixed and let the system solve for the latest stable that works with TensorFlow 2.0, as well as all the dependent libraries and modules that TensorFlow 2.0 relies on. So we solve that validation for you. Now let me go back and I'll quickly show you container profiles as well. This is the resources that are used in my Jupyter notebook. So let's take the default one, medium memory. And I can click in here and I can see that there are 16 gigabytes of RAM available to me in this container, right? So let's go launch it and launch a Jupyter notebook using one of these runtimes as well as that container profile. So I'm going to click in.
Zoom in a little
Hi, Meryl.
Can you zoom in a little bit?
Yes, thank you.
Thank you.
Is that better? Okay, so let me click into this notebook and you'll see the default runtime container profiles show up for 16 gigabytes. I'll open this. This is launching a container for my Jupyter environment behind the scenes. So if one is already available, let's say I had been running one for a prior part of the project, I can always go back and now all that container is already running for me. If I shut this container down and then go back and launch a notebook again, all of my files are actually centrally stored in the C3 server and in the file system. So and backed up and version controlled and for disaster recovery, et cetera. Now, so if I launch a new container, let's say I went on a 2-week vacation, I came back, launched a container, all of my files would still be here. The only thing that gets refreshed when I relaunch a new container is any in-memory computation that I did in one of these cells. And so now I'm in a somewhat plain vanilla Jupyter environment, but it's containerized, and I have, you can see the 16 gigs of RAM available just to me, even though these notebooks are shared in this tenant, this environment with other data scientists. I'm given my isolated compute environment. Now, remember we specified that that PyTensorFlow kernel, and you can see that that's loaded. Right now I'm running Python, the standard out of the box Python 3 kernel. If I want to go in and load into my container any of those other kernels that I showed you in the previous module, I can go here and look for those kernels and simply install them. And what that does is synchronizes, it loads all the libraries and the dependencies from the previous screen that I showed you in app settings. Now I can go in and import libraries and do the things that I would typically do as a data scientist. The key thing to mention here is that we have a global variable called C3, which is automatically authenticated and authorized to view certain parts of the data that I, as a user, can view. So think of this as a Python SDK connection. And what the C3 global variable allows me to do is here I'm working on a data model that has it's building a hard drive predictive maintenance demo, and hard drive is sort of the main table or type where all of the hard drive records live. It's just a table of data. And so what the global variable allows me to do is do autocomplete. I can look at the different methods that are available, et cetera. I can also look at the metadata on those types. So C3 hard drive help, I'll get a view of all of the metadata defined on this object. So the fields, as well as the methods, reference fields. So this is a reference to another type where my telemetry data are stored for temperature and vibration and uptime, et cetera, switch count, and all of the different methods. And on these types, I can write my own methods, right? I can go and create additional APIs and put them on this object hard drive and expose them as APIs. For example, maybe I want to create a method on hard drive called, get failure score. And what that API does is goes and looks at my latest prediction stored from my machine learning models, gets the latest failure score prediction from the latest version of the model that was trained for this hard drive, and returns the result, right? And so, you'll have all of these types predefined for you for the COVID-19 data set out of the box, and a demo notebook will allow you to kind of step through and get an example of this to get you going. But these types can always be extended, for your own research. Another example of what you can do in Jupyter is do some introspection and visualization of the data model under the hood. Now, this is a pretty simple data model for hard drive predictive maintenance. The main object is hard drive. This is the main table, there's another type called hard drive failure score history, where I'm storing my records, and hard drive measurement series is where is the time series header for my measurement series. And in using this visualization, I can quickly kind of navigate what data are available to me on these types. I do want to quickly address a question that came up. I know I'm talking about, I mentioned TensorFlow, but I do want to mention that PyTorch and Keras and other open source libraries that are available through any open source Conda channel or pip you do have access to those. So you can choose those libraries and you install them and do experimentation in a very custom way, as you would normally do in your environment. So let's query some data. So now I have hard drive data. I want to fetch some data. I'm going to show you an example of a method called fetch that's on hard drive. I can pass it a fetch spec and give it a filter, for example, an ID of the hard drive, and limit it to 5, and run that, and I'll get just a pandas data frame back that I convert the response to a pandas data frame very quickly. What this is doing is just fetching data on the hard drive type. But what's very cool here is we can also include additional fields from related types, related objects. So in the data model, I can see that my telemetry data are stored on hard drive measurement series. So I can include fields from hard drive as well as the measurements field, which if I went back to my doc, I would see that the measurements field, the measurements field is coming from this object hard drive measurement series, which is related to hard drive, but stored on a different table. In fact, some of these types are stored in a Cassandra high performance key value store, whereas hard drive is actually under the hood stored in Postgres. Now, as a data scientist, these high performance databases are optimizing my calls under the hood, but I don't have to worry about writing the SQL for the Cassandra fetch and then stitching it together with complex joins with a SQL query on Postgres. This include spec is allowing me to do the join on the fly. So now I get a response back that has my measurements. Measurements are multidimensional. This is time series data, so I can parse this out and go from there. What was the explain true? What I want to do is, this is an API, a parameter that allows me to show you what it would look like if I wrote that same query in SQL and and then it did all the joins. And so this is sort of the automated code that the C3 is handling under the hood for you, the DDL, and getting all the information and joining it from the database. So as a data scientist, I don't need to worry about doing that. I can just fetch my data and work from it, and using my favorite packages that I've installed, for example, pandas. And from here, if I want to get into more complex, I have my data in memory. It's in this containerized environment. I can start doing machine learning on it using the libraries that I've installed. We do have some advanced APIs like the time series designer that Riley showed you. You can also experiment with those and prototype those time series metrics in this Jupyter Notebook environment. We have a feature store under the hood, which is persisting all of these engineering features for you. You can visualize. This is starting to look like probably a lot of the Jupyter experience that you're already accustomed to, as well as configure and train machine learning pipelines. And that looks a lot like the scikit-learn pipelines. If you're familiar with scikit-learn pipeline, you're identifying these as pipes and then stitching pipes together to create pipelines, and then processing, training, testing, and scoring that pipeline as an entire unit. And then that pipeline gets persisted in the database, and as well as the entire spec for that pipeline, so that it's reproducible and traceable. So I can always go back and track what progress I made on those pipelines. Now, the next thing I would wanted to show you quickly is back in ML Studio, I can do more advanced things. I showed you the experiments tab. I won't go into too much detail here, but we do offer for ML pipelines a hyperparameter optimization wrapper. So I can kick off a workload. This is looking into a hyperparameter optimization process that does 60 different iterations and then comes back to the best models. I can do things like add, look at all my hyperparameters, sort by these columns, and try to understand what the trends were, which hyperparameters were important, and this can maybe inform some additional workload, workloads that I kick off. This is all automated on an auto-scaling cluster behind the scenes, so I can kick these jobs off, and I don't have to spend my weekend writing down all of the different parameter settings that I'm running for my jobs. As well as there's model tracking over time. And performance tracking of those models, et cetera. Now, I would leave the demo at that, and probably with the time remaining, pass this back to Meryl for any additional questions in Q&A.
Before we go to the Q&A, Human, do you still want to go over the curriculum?
Yes, Meryl. Let's.
Okay, great. Thanks.
Okay, so sorry, I think that should work now. So I think, thanks Jake, and thanks Riley. So I think what we want to also cover is, look, there's a lot in C3's platform. We've spent, a significant amount of time building out this kind of end-to-end capability. We have a curriculum, right, to learn about C3, and it's generally the fundamentals course is about 30 to 45 hours. It's offered online. And it covers the end-to-end platform. Now, there's different components of it that people can focus on, but we do have an online course that can be that we're making available to DTI through developer.c3.ai. People get access. They take the course, and then it starts every Monday. And the reason for that is every Monday morning we start the overall course so that we have things like office hours, environment access, so on and so forth. Each course must be completed in 1 week, and then we do ask for 5 days in advance because we're actually setting up environments, automated setup of environments for each course itself. And then we have an online community, and we have general support as well. Now, outside of the course, we will publish in the curriculum itself kind of a little bit about, use cases, right? So what the technology does, a little bit more deeper view of kind of C3 AI's capabilities, C3 AI overall as a company and where it's going and what the overall direction is and the types of use cases that are being done. We have a white paper on the technology stack. And then we have customer videos of large-scale deployments of C3 at companies like Royal Dutch Shell, Enel, 3M, and others who are using it to do large-scale kind of AI in a production environment. Now, there's 3 courses. The first course is fundamentals, and that's really the fundamentals courses. What is the platform? What is the type system? How do you do data integration, time series, and basic machine learning? We have an advanced data science course that goes deeper into how you can use C3 for machine learning pipelines, machine learning model development, jobs, analytic data flows, Python APIs and runtimes, NLP, deep learning. And then we have advanced app development for people who want to use it to build out applications that are then shared or used by others as well. So that's really the curriculum. That's also being made available to DTI. I think what we wanted to do now is really open it up to the Q&A. Any questions that people may have, and between Riley, Jake, Meryl, or myself, we can help answer. And Shrikant, we can help answer. And then the Q&A is on the right-hand side. I believe you can ask a question, type it in, and then we're able to see it and kind of repeat the question itself.
Yeah, so the first question that came in is, many of the data sets to be hosted within the COVID data lake are likely being updated in real time. Is C3 going to keep the data lake up to date?
I can help answer that. Yeah, so our what we're publishing on April 13th and then again in May are the data sources, the graph, the API documentation, and we have built capabilities to automatically update that data as it's made available. So as the data sources that we've published receive updates, we are automatically updating that data as well, so that when you're accessing the APIs, you're getting the latest data that's available.
Yeah, and if I could just very briefly add to that, this is Riley. That's really a core competency of the C3 AI suite, right? As a data scientist, you're probably very familiar with downloading a CSV one time onto your machine, and then at some point later making a decision to go download the CSV again and dealing with it. With the C3 AI suite, that's not really how you do it. You build a live connection, we make it super simple, and then the data is automatically ingested either on a schedule, or you can make a button if you'd like, or it can be automatic. And that's really one of the core competencies of C3 is live data integration from a variety of data sources kept in sync.
And then a question related to that, Riley. As the data set is likely changing over time, does C3 version the data lake? If I produce a result and they then want to reproduce it, can I call upon the version of the data lake I used in the past?
That's a great question. So C3 provides data versioning out of the box. And so what that means is that if, for example, data is updated and a new version of that data arrives, you can define on your data model that you want to keep the version of that. Now, we make you define that because, of course, there is a cost associated with keeping multiple versions, especially if it's terabytes and terabytes of data. In this case, it's really not. I don't believe at this time we've actually turned that feature on in the data lake, but it's a really good suggestion. And actually, I'm going to go tell them to turn it on now because we should probably be doing that.
Another one here. If I wanted to take my analysis off C3, can I download portions of the data lake, assuming I have a hard drive and internet connection? Presumably, the data a scientist would want to save would probably be these already solved queries to the federated data lake. If it's possible to download data lake, can it be downloaded in this pre-processed form?
Yeah, I can answer that. So yes, I think
it's possible. Yeah. Go ahead, Human.
Yeah, no, it's possible, of course. So I think there's two methods, right? So there's the DTI, and we're making that data available in the DTI clusters as types as Jake showed. So you can just access them and get access to them. Every type has an API. You can export that data if you want. But also what we're publishing on the website, c3.ai, I think /COVID, is APIs to the data itself as well. So both are available. You can, they're APIs. You can access the data and do what you want with it.
There's a next question, and I'm going to direct this one to Shrikant. How much detail is expected on the proposals about the use of the AI suite? Is a high-level plan on how the data and machine learning tools will be used sufficient?
That's a good question. Yeah, we don't expect you to be experts on C3 AI before you start using it. As was mentioned, there are courses available, and so if you get a grant, you'll be given access to a 5-day course that you can learn from and start using C3 AI after that. But I think what would be nice in the proposal is to show that your proposal is something that can leverage the C3 AI suite on Microsoft Azure. I mean, that you would need the kind of capabilities that we make available. If it's a project that doesn't require the AI ML the suites that we make available, then that is probably not the right kind of project for this institute, although we'll consider anything that's submitted. But if the project can leverage these capabilities, that would be ideal, because that's the unique strength of the institute.
Thank you, Srikant. I have a question for Jake here. Auto scaling of analysis on big data is awesome, but even your system is not infinite. With many people using it at once, when will we reach a point that the analysis could no longer be scaled out? How far can we hope to scale?
Right. So we do provide. That's a great question. We do provide an auto scaling cluster, and that the machinery can be also specified to be specific types of workloads. So if we need a high memory machine, we can specify that particular machine to come up just for your workload. And the same thing goes for Jupyter Notebooks. Is, you know, if you need 64 gig container, if you need 128 for whatever reason, that's all configurable in the system. Now there are some certain components of a full stack, for example, a Postgres database or a Cassandra database, that don't auto scale in the same way. But that's, you know, those are also things that do scale out in C3 AI Suite that we'll be monitoring and keeping going along the lines.
Thank you, Jake. Human, I've got another question for you. Many of the data sets to be hosted within the COVID data lake are likely being updated in real time. Is C3 going to keep the data lake up to date? And if, for example, more COVID CT scans are made available from a different source, how do we add this existing source to the data lake? Will we email you?
Yes, that's a good question. So I think I answered the part of the question already, but yes, we are going to keep the data up to date for the data sources that we have that are available. We are, I mean, we've been approached by the CDC, NIH, and others, and who would like to use this data set as well, and who would like to contribute data. So I think what we're going to end up doing is continuing to enhance the roadmap of data that we add. And if you want to ask for data or give us data, on the c3.ai/COVID website, we have a little form that asks people to provide data. We want to make this as rich as possible. We want to keep updating it. We will maintain it to keep up to date. And we want to keep adding the right data sources. So my recommendation is either email us or through the website itself, the API documentation website, we allow you to ask for other data sources or let us know where else to add them.
So I would just like to add, this is Riley, that's really in the context of the data lake, which is a related but separate project. As a DTI researcher, you'll have access to the full suite of C3 AI Suite tools, which means that you can actually extend the data model yourself. And one of the things that I'm hoping will come out of this project is that, I know this isn't what you guys will probably be caring about for now, but I hope that some of you guys will find new interesting data sources, add them to the data lake, publish those on the marketplace like I showed you. I'll be scanning that thing every day and looking for interesting data sources, and I will probably try to consume those to expand the data that's in the data lake for the public consumption.
Great. I have another question for Srikant. How will proposals be considered that use C3.ai but also use other systems? Can we propose systems that interoperate with C3.ai but also leverage other outside COVID-19 resource and platforms?
Absolutely. Our only request is that everything be open source. I think that's something that the Institute strongly believes in. And if your algorithms and software and the papers that you write that come out of it, they are all made available to everybody in the world to use, that would be great. Other than that, like Jake pointed out, you can write your part of your code in something else, pull it into C3 AI, that would be perfectly fine, and that would be okay. Yeah.
I've got another question here for Jake. Thank you. Jake, how to incorporate a large collection of domain-specific libraries and tools, such as geographic information systems, into C3.ai?
Yeah, so the existing capabilities that I showed, if you can install those from Conda, pip, CRAN, that's something that you can just install and set up as a runtime. You can also go and specify your own libraries. So let's say I wrote some custom Python code or I wanted to pull in an existing library and then make some modifications to it, I can write that as just a pure Python, pure R, pure JavaScript piece of code and expose that on one of the models, and then deploy that and make that shareable to the community.
There's another question. Across how many nodes can we hope to scale out machine learning runs to parallelize analysis?
Great question. I mean, we've scaled to hundreds of nodes for auto ML workloads, that need to train millions of models in production settings. That's actually a real use case that some customers have. So it is horizontally scaling, and those limitations are can be basically set by an administrator that will be watching over the performance and cost of the system. But let's see what we can do. There's really no I won't give you a limit.
There were also a couple of requests to make a recording available. I heard that not everyone could read the whole session, so we can see how we can improve that and make that recording available. Those were most of the questions. Oh, there's one more coming in, and we have 2 minutes, so that's perfect timing. Is the suite integrated with GLEAM, G-L-E-A-M, Global Epidemic and Mobility Model platform developed by Vespigiani from Northeastern University?
No, we have not. That has not been integrated. We can look into that. That has not been integrated.
I mean, the question was, is it interoperable though? And so I think the answer is that as long as it's available via REST API or really any sort of URL, we have tons of experience integrating with external systems, and there are tutorials built into the platform that show you very simply how you can integrate with any external system. So I think that this is really an open platform. You really can integrate with almost anything you can think of, whether it's a library, a system running out on the internet somewhere else, a data set. We really are built to have applications that run at scale in production, and production systems need to be constantly getting new data, interoperating with other systems, and having real load on them. And so this is really the strength of the C3 platform.
Thank you, Riley. Srikant, I'll give you the last minute, and maybe you can answer this last question that came in just at the last moment. Can we connect to private data sources with proprietary data as well, i.e. data that can't be transferred into the COVID data lake for the research of the DTI?
That's an interesting question. I guess if there are privacy and anonymity issues, you'll have to deal with those. I don't know. I have to look at the data set and get advice from the experts before I can really answer such a question. But yeah, it's a tricky question because it could be health data, it could be mobility data. I don't know how one is, what requirements you have in handling those.
All right, with that, we've came to the end of our Q&A. Srikant, the final words from you.
Okay, well, thank you everybody for listening in. And if you have any questions, please contact Shankar, me, or Jay, or the two chief scientists of the Institute, Tandy and Costas, and we will either answer the questions or direct them to the experts to get the right answers for you. Thank you all. Bye.
Bye.